So we're going to start, even though not everybody is here, obviously, with our keynote number 4. And it's Christoph Jentzsch, the founder of and CEO of Slock.it. Please come to the stage.
Oh, that's the mic just works. This works better. So not everybody back yet from lunch, but those who are here will get some good content, I hope. So let's give you a short introduction of my history. So I started to work for Ethereum in summer 2014. So I was part of the team who created Ethereum. Then we created Slock.it at the end of 2015. What we have been maybe most famous for was infamous for was our involvement with the DAO. I think some of you know the project and how it ended. Today I will speak about the Slock.it IoT layer, so basically what we did afterwards. So the projects we did, we have now a lot of years of experience where we built real case scenarios beyond proof of concepts, things that actually went live. And I will just talk to you about the problems we found and how we solved them, and give you a quick overview of this. So what's the main story? So when I thought about what to use Ethereum for, I thought about connecting machines to each other. I think there's a far way to go for Ether or any other cryptocurrency to really be used as a cryptocurrency by the mainstream, but being the currency for machines, this is something I strongly believe in, we already can see today. So for machine-to-machine connections. And the interaction with machines are at least threefold. We have human-to-machines interaction, and that's something which already works today. So we have our Slock.it app in the App Store, where you can connect, for example, a smart door lock to the blockchain, to a smart contract to be more precise, and someone else can pay the lock in order to open it. So you can think about Airbnb use cases or other things where you just pay for access. That's the basic idea. The next one, which is more interesting, which is maybe not in the near term but mid-term, is machine-to-machine communications. So we have worked on autonomous cars which have a wallet, so that cars can, for example, pay for charging. Cars could pay for parking. Cars could pay for toll collecting, and all of those things. And human could then pay cars in order to get from A to B. So I think the use case of having one machine paying another will open something we like to call the economy of things. And there's a lot of use cases out there. Last one is machine-to-human interaction. We had one company approaching us who was basically cleaning houses and was asking if the cleaning staff could not be paid by the door lock itself. Because sometimes people didn't show up, didn't clean actually the rooms, so why not having, when the cleaning man or cleaning lady comes, checking in, checking out, and getting paid by the door lock itself. So this would be kind of a machine paying human. Or another example would be a car driving to the garage, needing to change the tires, and the car would pay those men doing it. So there's a lot of cases actually for this. And so those are the basic interaction with machines. But there's one big problem of this machine economy. First, machines don't have wallets. Second, there's no or insecure interoperability and a high security risk. I sometimes say the S in IoT stands for security. There is none, because if you think about IoT today, you can really hack into almost anything. They usually have the choice between security or interoperability, meaning you either close the system down and nobody can connect to it, then it's pretty safe. Or you want to integrate with IoT cloud, third parties, and so on, IFTTT, and all those nice protocols, but then you're often very vulnerable to attacks. So the question is, how can we solve interoperability and security at the same time? Blockchain can solve some of it by giving wallets to machines, but just giving them private keys. The blockchain itself can act as a distributed standard. Something, it's very hard usually if one big corporate puts out an IoT cloud, the others won't use it. But if you have a distributed standard like the blockchain, people can agree on this. You get the security blockchain gives you and the transparency. But now there's a problem. I don't know who of you have tried actually to build something IoT related on a blockchain. You need to connect the IoT device to the peer-to-peer network. And that's actually a huge problem. It's unfeasible to run a full node, sure. A pruned full node, which is for Ethereum about 40 gigabytes, still way too much. And people thought that light clients were the solutions, also for mobile wallets, but they are not. And the reason for this is the need in bandwidth. So we did a feasibility study with a German car manufacturer to try to put a light client inside the car. technically it works nice, but the bandwidth requirements are so high that it's completely unfeasible to do this in real life. So what people usually do, they just use a remote client, meaning you run a client and connect to a server somewhere from AWS or somewhere else. So that's actually not what we build blockchain for, but just having the blockchain run inside of AWS and then clients connecting to it. So how can you solve this problem of connecting small devices, or even cars or mobiles, to the blockchain without running a full node, pruned node, or light client? So we have come up with a solution we call InCubed, which stands for a trustless, incentivized remote node network. I will try to explain you shortly how this works in one slide. So the idea behind this is this. Now let me give you a little bit of technical background. So when you run a light client, what does it actually do? A light client synchronizes with a peer-to-peer network of any blockchain system, only the block headers with the goal to achieve at the last block header. And once it has this last block header, it doesn't store all the states and all the transactions, doesn't execute any of it. All it does is it receives Merkle proofs. I don't have the time to explain you exactly how they work, but they are basically a proof that a subset of a larger data set is belonging to it without the need of getting the whole data set. So you give the Merkle proof and you need the correct block header. And for getting the correct block header, light clients synchronize the whole chain. And here we make a shortcut. We say there are full nodes. Here you see node A, B, and C. They are fully synchronized. They store everything. And what they do, they pay a deposit inside a smart contract, which is laying there. And in the case some would find that they are lying or cheating, they would lose the deposit. So and the nice thing is you can verify or prove this inside the smart contract. So how does the structure now work? You have those nodes, they are running full nodes, and you have clients like IoT devices, they are asking for data from the blockchain. We call them RPC requests, remote process communication. And they ask for, the client is asking here, for example, node B, please give me an answer to my response, and let node A and node C sign it. With signing, I mean signing the block hash. Then node B collects the data, gives it back to the client, and the client can then first verify the Merkle proof. Second, it gets the block header and builds the hash of the block header and can check that node A and C actually signed the correct block header. The nice thing is, so what is if they are lying? What if node A and C are signing a wrong block header? Node B would find out. The client could even publish this. And if anybody finds a wrong signed block hash, he can go to the smart contract and claim the deposit. So what do you get? Something like a little bit of proof of stake on every chain. Because everybody can run a node, everybody can stake or deposit some of their ether or whatever coins they use, and say, that's what I would lose in case I lie. And then they can serve those clients, and we like to call them also minimal verification client, because all they do is verifying, not synchronizing. A big difference. And with this, they only need minimal storage. They just need to store the actual software itself. They don't need to store the state of the chain. They don't need to be part of the peer-to-peer network. They are very lightweight. We actually have a chip which costs less than $2, which can run such a minimal verification client or InCubed client. So with those chips, you can actually get inside devices. So this is the basic mechanism. What I call watchdogs here is basically everybody can check that those signed block hashes are correct. Here in this case, it's node B checking, but the client could also ask other servers which have registered in the InCubed smart contract to see if they can check those block hashes. Okay, this is the part of the smart contract, this secret sauce, so to say. This is just a little bit of Solidity code showing how you can prove that someone did actually give a wrong response, only for the developers here. But this is now another nice feature which comes with it. Today, there is no blockchain client which can simultaneously sync to several blockchains at the same time. You're either in the Ethereum network, or you're in the Bitcoin network, or EOS, or Neo, or whatever you want, or in a private Ethereum chain or other chains. You usually just choose one. This InCubed client can be simultaneously be connected to many blockchains. Because it's not syncing, it's just verifying. So as long as it knows how to connect to one of the nodes in this network, and at which smart contracts those nodes are registered, it's all it needs, because then it can ask for request and verify the response. And that's a very nice feature for something which fits within a $1 chip. to be synchronized to all of those, not synchronized, but can talk to a lot of those chains. Maybe when we speak about this, sometimes people say it's very easy to connect devices to the blockchain. You just store a private key in a device. But this is actually wrong, because opposite to what people usually think, in this scenario, it's easier to write to the blockchain than to read from the blockchain. In order to write, all you need is a private key and signing a transaction and send it to the network. But in order to know if the transaction has made it in, this is actually a read access. So how do you do this? In order to read and check this, we actually need to synchronize the whole chain and verify it. So the much, much bigger problem in blockchain is reading from it, not writing. And with this system, you actually can securely reading and verify the response. So this system now is only part of something bigger we are building. We call the Slock.it IoT layer, because in order to build applications, real-life applications on top of a blockchain, for someone who doesn't know the details of it, we need much, much more than just a client. We need much more tools. So the client, the minimal verification client, is just the core part of it in order to connect the device to the blockchain. We also have built payment channels based on Raiden, so you can do micropayments. We have a search and discovery service, similar to like a telephone book for IoT devices, so you can find them, see what services they are offering, what functions you can call for them. Access control smart contracts. They are, I think, one of the most important features. If you look at smart contracts in Ethereum, 90% of them are just managing permissions and access. They're just checking if message sent equals someone, they can do this and that. So this is what smart contracts, I think, are most useful for. And we are using this to managing the access or permissions to certain IoT devices. For example, who's allowed to use this car? Someone who paid, or someone who's standing on a whitelist, or who's allowed to enter into this apartment? Someone who fulfilled some criteria which you can find in the smart contract. And then the device itself is connected to the blockchain to read from those smart contracts. We have integrated payments, of course, Ether, ERC20 token, a Euro token, Bitcoin. Also, Fiat is integrated via a Stripe integration. We have integrated this in IoT cloud, such as IFTTT, Arctic, Nuki, and others, so that if your IoT device is already connected to one of those IoT devices, you can then connect it through our system to some smart contracts on one of those chains. Messaging through metrics, multi-chain support, I just explained to you what this means. And IoT integration, I mean, we have already worked on Raspberry Pis, Arctics, and other chips where we have a finished image which we can give you, which you can just start and using. Okay, what features does the system give you? Well, you have interoperability, because now everybody who wants to use the system just calls the smart contract. The smart contract, I like to call a direct API, not just an open API. Clouds and other systems usually speak about open APIs, but it's just a black box where you call in and hope to get some response. A smart contract is something you can read and verify, and gives you direct access, and someone can build a third-party applications on top of your solution or your IoT devices. They just need to know how to call your smart contracts. Get security of a blockchain, you have no single point of failure. If Slock.it would not exist anymore, the system would continue to operate. Because this just is, we are helping you to connect the device to the blockchain, but not to our servers. There's no login required, because you can just use your keys. You have full permission management through smart contracts, full payment support, transparency, and something very important, app coin free. There's no need to launch a token for such a system. And to not having done an ICO gave us a great benefit in the real world, because those big corporates, it's much easier to sell them a license than to say you have to buy my token in order to use my product, which is for them complete nonsense. So, and why should I buy a volatile token just to use your product, and I have to ask my legal department, it might be a security, you get to all of this hassle. But if you just sell something, which is software, and you license this, we do is to do a license, an open source license for non-commercial usage, and a for-profit license for commercial usage. So, and because we are AppCoin free, we can actually operate on every blockchain out there which supports smart contracts. So we are not bound to one ecosystem because we have a token in this ecosystem. We can go to everyone because we are just providing solutions. So just giving you some cases where we already have done this. So our own product called the Universal Sharing Network is an end-user application of this IoT layer. What we do here is what I explained to you, connect devices to those smart contracts so people can pay or to get access. And this is used to share things. This is how the structure works. So someone registers a device such as the apartments through a smart door lock. Someone else with our mobile app can find it, and within the same app, he finds it, he pays for it, and he accesses it. He can basically use the app to open the door itself. This is all within one system, and this is fully decentralized. There's no need for our servers, because the IoT device, here you see the smart lock, is just connected to the blockchain, and your smartphone is also just connected to the blockchain. You buy access, and then when you're in front of the smart door lock, you just send a Bluetooth message with your signature. The door lock is checking the blockchain. Does he has access, yes or no? If yes, I open. It's a very simple system, and it's actually very secure. Because this device has no other authority than the blockchain itself to tell who's allowed to have access or not. We have used this system for another company called Share and Charge. Maybe some of you have heard it. They actually launched it over a year ago. They connected more than 1,300 charging stations through the public Ethereum chain through this system. This was, so Share and Charge is a spin-off of the company RWE, or later Innogy, in Germany. We also have helped Wirelane. They are building charging stations to integrate the system. So you have a decentralized network of electric charging stations where you can pay with your app, of course, but you also can pay with your car if your car supports it. We are working with car manufacturers to get this support. But to try to have an underlying platform, the blockchain itself, to do all those transactions, and not Slock.it or any cloud service. Okay, so with this now, we have 4 minutes left, which I wanted to leave open for questions. Because I'm not actually sure how technical the audience is, or how business-oriented the audience is, if I actually did help anybody to understand something. So we have, almost 4 minutes for questions.
Any questions? Let me see. Nobody has any questions? Oh, yes. Let me give you the microphone. Sorry. Like everybody can hear you.
Hi, Christoph. I heard about Slock.it a few years ago, and back then I understood that you wanted to somehow disrupt Airbnb or those kind of players. What I don't really understand is it like a vertical that you want to do, or do you want to just provide this technical platform and then people will be able to make verticals using your systems?
Good question. So our company kind of to say we have pivoted is maybe a strong word, but we started with this use case, that's correct. So we started with the door lock, then we found, well, the infrastructure for this is completely missing. So there's no way we can go live and in any way compete with Airbnb with this system, with this infrastructure. So we focused the last 2 years actually just built this infrastructure, what I call here the IoT layer, which you could say is the back end of this solution. And actually we had a lot of requests for this, so we kind of stayed with this for now. We said this use case is out there, you can download the app, but we are not focusing on it, we don't do any marketing for it, we just take it as a showcase, so to say, for now, because we as a company right now, I see ourselves as a B2B company providing software solutions to those companies and have this as a use case. So Share and Charge, as you saw it, using the same system, but you don't see Slock.it there, although it's powered by Slock.it technologies if you want. So the Airbnb use case, I'm saying I waited with this for later because as of today, Ethereum doesn't scale, people don't know how to handle their private keys. IoT devices, even those smart door locks, they work 90% of the time. But there are even there's a lot of work to be done in the IoT world and in the blockchain world before I think we are ready for such a mainstream application. That's why, as a company for now, we stay with the B2B solutions and seeing actually a lot of success there.
Any other questions? I'm right here. No? All right. Take this one. All right. Thank you so much.
Thank you for
That was
attention.
Christoph. Keynote number 4.